Maybe this time I'll remember. I was looking at some of the videos when I was uploading them. I keep putting my water bottle stuff like right there. So you kind of see me standing next to this huge water bottle. Maybe I'll remember not to do that. All right, so you can make corrections to this test just like any other test or quiz. When are they due? By the day of the next test, right? So you can turn it any time from today until the day of the next test. Even after that, just be late. Josh. Here you go. Okay. So if there's no other questions on that test, we're going to keep going. What is it that tells me when I need to change my standard deviation? All right, so when I take a sample and I want a probability of the mean doing something, right? So in one case, it should make sense. When I draw my original distribution, those are individuals. So this little dude that I normally am given is only good for how far individuals are from the center. The minute I say, well, what if you take 20 people? What's the probability that their sample mean will be blah? Now I'm comparing that to all the other samples of size 20. I need the standard deviation that's good for samples of size 20. So this is what I very often will call the new standard deviation. Because the work, the math is the same. You're just using this new standard deviation. So it took 2 sections in the book, a handout from me, and very interesting homework from you guys to really try to get through the concept. But the actual work is just not worthy of all that. Because all you do is you change standard deviation. Then when you do your z-score, you just use the new one instead of the old one. You still look it up in the chart, you still get the area, right? That's the only thing that really fundamentally changes in the problem. So, we have one section left out of chapter 6 to do. And then I want to get into 7 today. And the one in chapter 6, you remember that handout I gave all back with the coin if you flip it so many times? You don't remember that? I had the histogram right in the middle of it. Let's see if I still have a copy. Probably not. Give all mine away. All right. So even if you don't remember that, so if I flip the coin 14 times, and this keeps going on both sides there. If I flip the coin 14 times, what's my mean going to be for the number of heads I would get?
7.
Yeah, because it's 14 times 0.5. I expect to get half of them to be heads. And how do I get the standard deviation? Good. Square root of n times p times q. And what would that be? Somebody help me out there. 1.87.
0.8.
Cool. All right. The whole idea of section 6.6, if you remember this handout I gave a while back, it looked very normal. Probably more normal than mine on here does, but it looked very normal. It started low, it went high, it went low. Way back when we did histograms, some of the questions were asking you, does it look normal? Had to start low, go high, go low. If it's normally distributed enough, I'm allowed to use the z-score chart to find probabilities. That's the whole idea here. And somebody's done a lot of freaking work for me already. So this is kind of a small example of a problem that I'd want to be able to use the z-scores for. The problem with using z-scores here, when I drew this picture, when I drew this line over it, what's kind of wrong with that? Is this discrete data? Or is this continuous data? It's discrete. Why? I can't possibly flip 6.38 heads. Sorry. There's a finite number of things it could be that's 0 through 14, right? So there's no way it's continuous. When I draw this is continuous, isn't it? So here's the whole thing. If I want to know the probability it's 6 or more, or let's say, let's see something we can check real quick. 6 or fewer. So the probability that it's less than or equal to 6. So we can look that up in the chart. We will in a minute just to kind of verify what we get. But I can approximate the answer using a normal distribution. And it should make sense that I should be able to. I don't have a mean, don't I have a standard deviation? Can I make a z-score out of 6? Right? The trouble is, should I use 6? What is 6 really? I mean, it's not continuous. 6 is just 6. But looking at the bar here, I can pretend that it's continuous. Why is it not continuous? Because there's a big old gap between 5, 6, 7, right? But if I pretend, and this is where people don't like, I just say that myself. If I realize that 6 actually goes from what to what?
5.5 to 6.5.
5.5 to 6.5. Right? Would I be wrong really to say that there are this many heads between 5.5 to 6.5? There are, how many heads are there? Or how many times does that occur? You guys kind of with me? The only way that it could possibly occur is if it's 6. But is it wrong for me to really say between 5.5 and 6.5? No, it's not really wrong. It's just weird, right? How many would you expect to get between 5.5 and 6.5 heads? How many of those would you expect? Well, you just count the number of 6 heads because that's the only thing that works in there. But to make this continuous so that there's no gaps, I pretend that 6 goes from 5.5 to 6.5. Because what does 7 do? 6.5 to 7.5, right? Now, don't they run into each other? There's no gaps in between then. So really, what it ends up doing is making the approximation much better. And I really want you guys to, there's a main thing I want us to get out of this section. But I always want us to try to get the entire damn section. So the whole idea here is, I hope to God I'm able to use the normal distribution because I can use the z-score chart then, and that's easy. I don't have to do a billion calculations here, right? I can just get a z-score, look it up, be done with it. But in order to use the z-score chart, I've got to have a normal curve, a continuous thing. And these stupid things aren't continuous. 6 heads, 7 heads, 8 heads. They're not continuous. They're not sticking together. If I go from this to this, though, they do run into each other. It is continuous. So instead of making 6 into a z-score, how would you shade if you wanted to be less than or equal to 6? Would you want to include the 6 bar? If you want to be less than or equal to 6. Of course you would. So would you start on this side of the bar, or would you start on that side of the bar? That side. That's it. So don't make 6 into a z-score. You have to account for the fact that this is discrete, not continuous. So it's called a continuity correction. It corrects for the fact that it's not continuous. So whenever you're trying to take an NPQ problem, which is what we definitely have here, NPQ problem, and use z-scores to get areas, so I don't have to use the formula millions of times over, I have to adjust the number I'm given. And you can always do this. You can always draw a little box and just go, do I want to go up or down? So why did we want to start here in this case? Because I want to shade down and I want to count this bar, right? So if I had, for example, a little side note, if I had probability x is greater than 9, how would I change that? Would I go to 8.5 or to 9.5? Which way do I want to shade, up or down? Up. Do you want to include 9?
No.
Greater than 9? Is 9 greater than 9? No, I don't want to include 9. So do I want to start here and go up, or do I want to start there and go up? There. See how quick that is? Don't try to memorize when you add 0.5, when you subtract 0.5. Just draw a little box and go, do I want to start on this side of the box or that side of the box? In this case, I want to go from this side of the box. Why? I don't want to include 9. And what are we assuming 9 is defined to be? 8.5 to 9.5. So if I don't want to include it, I better start at 9.5 and shade up. So coming back here, my continuity correction is I make this not probably x less than equal to 6, but probably x less than equal to 6.5. Using the reasoning over there, right? I want to shade down. I want to include 6, so I better start at that wall and shade down. What we're going to do then is we're going to compare it to the answer we should get. We can look in the table in the back to see real quick what answer we should get. Now, if I make that into a z-score, 6.5 minus what? What's the mean? 7. What's the standard deviation? 1.871. So you guys help me out. What do you get? Negative 1/2 over that. Over 36. Over 18. A little less than a third, so it's like negative 0.29. Negative point, what?
Negative 0.267.
So like rounded to negative 0.27? Right? Okay, cool. Now somebody help me out, look that up. What area would that be below that? And that's exactly the area we want, right? We want the area below that. If you look at negative 0.27, what area do you get below that?
39.36.
I love it. All right, so just over 39%. 0.3936. All right, now hold on to that. Look on page, what page, Jeff? I don't know. Page, where is this stupid thing? Here we go. 603. And this is actually the copy of this table that I put in the handout with the flipping the coin thing. Right? Page 603. So that we don't have to do this formula over and over and over again. N is 14. P is 0.5, and I want up to 6, right? So if you look, P is 0.5 right in the middle. I get 0 plus 0.001 for 1. Because what is the question again? I want up to 6. So that would be 0, 1, 2, 3, 4, 5, 6 successes. The probability of 0 successes is basically 0. 1 success is 0.001. Plus 2 successes, where are you looking, Jeff? Crazy. 0.006. Plus 0.022. Plus 061. 1. I lost it. 122, thank you. 183. That's far enough, yeah. That's 6.